like, share, and subscribe to my YouTube channel. Thank you for your support. Welcome back. This is Jonathan Goldfish. This is the integration part 2. And now let's continue for the volumes of the revolution. Okay? So in the geometric, I have drawn over here. Alright? And the light blue color that I have highlighted, this is the region of the solid. That represents the volume generated, rotated through 360 degrees about the x-axis. So here is the formula given in the integral form. Okay? Of course, with the limits from a to b. So how is this formula derived? So look over here. Okay? So here is the proof. So without considering the entire solid, let's check about a disk only. A disk is actually the circle geometrically. So what is the area of the circle? Of course, everyone knows that it is the pi r squared in 360 degrees, right? So this is for an area of the disk generally. And what about for the bigger disk? This is the bigger disk or the largest cross section. And this one goes for the smaller cross sections. So what you can see over here, each big and small has the unique radius. Or you can say that it is the largest radius and the smallest radius. So the radius interpreted geometrically in the Cartesian graph represents the height or the functions. Okay? So now we have the area of the disk already. Okay? And then that is the height for the solid, which is the sum. The height. Okay, now for height of the solid, to combine from the bigger disk slowly to the smaller disk. So this is the small change of the width. Okay, so you add up each of the small change of the width, it gets smaller to smaller until the smaller disk. Okay, so since we can't determine how much exactly the disk it has in the combined solid, okay, so we have to use the integration to maintain its accuracy. So you know that this is the volume of the cylinder, but unfortunately this is not a cylinder. Okay, so to determine how much exactly the volume is, so we have to use the term integration or the sum. So that's why I have to write a proximal equal sign over here for all of the volumes combined together. So this is just an approximation. So to get the accurate value of the volume, of course it is in the integral form. So the summation of the v is required for the small change of the x is approaching 0. Okay, by considering each disk has the different radius. So the radius represents the functions for each domain or each x values between a and b as long. And we assume that each of the different radius of the disk consists consists of the same height, which is the change of the x. So we just this is not the matter of the radius, it's the matter of the small change. So we can't determine how much exactly the small change is. So we have to use the summation. And of course the limits. For the small change of the x approaches 0. Okay? And therefore we have summarized that the volume formula rotated through 360 degrees about the x-axis is the formula written over here. Okay? So it's a v is equal to the integral from a to b pi times fx bracket outside square. So this is the area of the circle or area of the cross section. What about the height? Is the sum of the change of the x. Okay? So this will be our height for sure. Okay? Therefore, it is proven for this formula. Okay? So what if you are given to integrate the volume, but the question demands you to integrate the find the volume in the integral equation where the function is rotated through 360 degrees about the y-axis instead of the x-axis. Okay? From a to b. But the fact is, you must convert the limits into y values if only the x values are given and also the functions. Okay? So, this goes to the same concept as above. V is equal to, there is a pi, yx squared. Because we take the inverse from y equals to fx to x equals to fy. Okay? I mean, x is the function in terms of y. Alright? And then you square it up. Remember that the square is the entire square of the inverse function that you have converted or derived. Okay? So, no words over here. It's just the same thing as above. But remember to convert the dx to dy and the y into the x in terms of y for sure. And the limits are also the y values for both. Okay? I hope you got this. Alright? So yeah, let's move on to the improper integrals. Oh my god, guys. We are finally entered the last subtopic among this topic. And also among the pure mathematics one. Finally, we have made it here so far. Alright. Here comes to the last subtopic, which is the improper integrals. Okay. So what you know about the improper integrals is when the integral seems to not to be integrated. Alright? So there are few scenarios that you should know. First, integrals with the infinite limits. What does it mean? It means that one of the limits is, or both limits has or have the undefined values, right? Knowing that the fx is the defined and continuous for all x is greater or equal to a. Okay? So, this subtopic is not likelihood to come out, or it's hard to come out, but you still have to grasp this concept. Alright? Somehow in engineering, it is as the one of the applications that you should utilize. Alright? So, if you are dealing with the integration, okay, fx from a to the infinite, so it's impossible for us to integrate it directly. Instead, what we can do is we introduce the limits, just that the limits is replaced, the infinity can be replaced as one of any variables. To make it the limits of the b infinity to the integrals of the fx from a to b. Now you make the integral proper already. So which means that you can integrate it as usual. However, you have to substitute all the limits after it. Then you take the limits. Alright? Evaluate it fundamentally. Alright? Okay. Or if there's another case that but fx is still a continuous function in the intervals for the x is less than b, negative infinity, that's simple, replaced by a proper variables to make and that integral term to be proper to be integrated by you. Alright? If the limit exists. So, we have finished discuss about the integrals with the infinite limits. Okay. Guys, moment of the truth. We finally made it to the last segment among pure mathematics one. Integrals with an infinite discontinuity. So, about this discontinuity, it depends on the function that seems not integrable, right? Like the fx is generally defined and continuous, but not defined for the intervals required after you have integrated the fx already. So instead, you have to take the limits. The limits replace the intervals with another variable, okay, to make it valid. After you integrate it, substitute the limits, then substitute the limits of the integral, then you take the limits as c goes to a. Alright, no matter positive or negative. Okay? So in summary, to integrate with the infinite discontinuity, first, find out that what is the integral of the fx, which you will get in another form. But in your syllabus, it only involves the algebra or polynomials. So which means that the integral result, I assume that it's polynomials. So after you integrate the polynomials, substitute the limits, just that one of the intervals might not be defined for the bigger fx. Okay, let's assume that the integrals of the fx dx is equal to the bigger fx neglecting about the c, because the integral is definite integral. Okay, so for example, fb might not be defined. So instead, you must replace the b. B can be the real numbers with another variables. Okay, convert it into the limits form, and then these limits must be taken eventually. Alright? Same goes to the below one, and I'm not going to repeat because this is for the another side of the limits. Okay, so until here, this scenario doesn't seem to come out easily in your external examinations. However, for the February March student, it exists. So for the May, June, and the October, November series candidates, you still have to grasp this concept. Okay? Even it doesn't exist in your A-levels, but however, in your future career, especially in engineering mathematics, this concept must be used. Like Jonathan Goldfish, me, I'm now already in the university to pursue my undergraduate course. Okay? So, guys, congratulations! We have ended the lecture for the chapter 8. But one thing, it's about one thing we have to face over here. The last thing last. Please, guys, be persistent. Alright? Be persist. Alright? So, since we finished all the lectures, but not so fast. We still have to go through our exercises. Let's proceed to the exercises, shall we? Guys, keep going. Last already, please. Alright? So this is the exercises for chapter 8 before we end the pure mathematics 1 journey. Okay? So before we begin our exercises, here are some advice. Alright? Don't overconfident. If you think that pure mathematics 1 is easy, but lack of practice, you still mess up. Right? My second advice is keep persisting. Alright? Practice makes perfect. Try to do other passing questions. Alright? As over here, I have discussed the limit numbers of the passing questions, as I have the other busy times. Alright? To pursue my courses. Alright? So please, in mathematics, practice makes perfect. Alright? So hopefully you listen to my advice. Alright? So this is the exercises for chapter 8. Alright? However, for chapter 8, I'm gonna tell you that these exercises consist of the most questions among pure mathematics 1 compared to the previous few chapters in our lecture discussions. Alright? So out of the 55 questions, I'll only discuss 70 questions. Okay? So as the same segments, let's start from the course book questions. Okay, question 2. Find each of the followings. A. The integrals of the 12x to the power of 5 dx. So how to get the integrals of it? Since 6 of these integrals are indefinite integrals, so which means that after you integrate, you have to add the plus c. Remember. So since this is AS syllabus that involves polynomial integral only, remember the rules. A and the integrals of the x and dx is equal to the x at the power plus 1, then you divided the n plus 1. Don't forget the plus c. Alright? So recall this using the rules record over here. We will get 5 plus 1 is 6. 12 over 6 you will get 2. So 2x to the power of 6 plus c. This is the result. Okay? Second, integrals of the 20x cubed dx is equal to what? Please try for yourself. I give you the answer only. You will get 5x to the power of 4 plus c. For part C, what is it? It's negative 3 x to the power of negative 1. Or you can put it in the fractions as you wish. Okay? So this equivalent form answer seems to be nice, to be neat. Alright? D. Integrals of the 4 over x cubed. What will it be? Negative 2 over x squared plus c. E. The integrals of the 2 over 3 square root of x dx. What will it be? It's 4 over 3 x cubed. Sorry, it's x square root of x plus c. Okay? Here will be the answer. And finally, we are touching the last part. What is it? The integrals of the 5 over x square root of x dx. What will it be? So here is the tactics that I can teach you over here. If you have the bad fundamentals, so let Jonathan Goldfish teach you over here. What you can see over here, x is the x negative 1. X negative 1 times, what is it? Times the x negative 1 over 2 dx. So using the indices addition rule, this is 1, negative 1 over 2, it's addition. Alright? So you will get x to the power of negative 3 over 2 and integrate it easily. Okay? What will it be? It is 5 times x 1 over 2 divided by negative 1 over 2 is actually basically times negative 2 plus c. Don't forget, you will get negative 10 x to the power of the negative 1 over 2 plus c. And if you want to write it back to the square root form, okay, yes, you may. go on, you will get like this. Can, it's acceptable as long both answers are equivalent, then correct. Okay? So see, this basic integral, indefinite integral questions, each of it is very simple only. So who says that pure mathematics is difficult? Alright? So hopefully you can understand what I'm trying to explain and the guides, right? So now let's move on to the next question. Alright, let's move on to the next question, which is the question 4, but it's still under the course book questions. So this question is about the finding the equation of the curve with the two unknown. Okay, when it comes to the two unknown, what we will do is we have to solve the two simultaneous equations. So here's the guide. Very, very general this question in your external examinations. So please watch this guide carefully. Given a gradient function dy dx is equal to the kx squared minus 12x plus 5. So where k is the constant, but the k is unknown. However, you still have to find the values of k as well as the c after you integrate it. But no worries that, please rest assured that the points, the 2 points are given that lie on the curve. Okay? So what you can do over here is to integrate into the equation of the curve. Although it's incomplete, but at least you obtain the form already. So how to integrate the quadratic function below? Remember to put log s sign because it's very useful for the method marks. Alright? So this is 1 over 3 kx cubed. This is 6x squared plus 5x. And don't forget the plus c. So now, apart from the x and y, there are two unknowns, which are k and c. So which means that that's why 2 points are given for you to find the k and the c. Okay, this is for you to build the two simultaneous equation in terms of k and c and solve it simultaneously. So over here, follow this step carefully. At 1, -3 as the first point that lies on the curve. So y is -3. What is x? It's 1. Okay, doing this way, you will get two terms, which is half k plus c is equal to -2. This is your first equation. Now obtain the another equation, which for the point 3, 11. So put 11 inside. Half k and then 3 cubed, -6, 3 squared, plus 5 times 3, c. So this is 27 over, 27 over 2, k plus c equals to 50. So this is your second equation. Now for me, I feel like in my own preference, I'm gonna use the elimination methods. But if you want to use substitution method, okay, it's up to you. As long you are able to solve for the k and c, then rewrite the equation of the curve as your final answer. So for me, I will say that equation 2 minus equation 1 to get the k first, which is 27 over 26k over 2 equals to 52. So the values of k gives you 4. Okay, integer as an integer values or the real constant. So now substitute the k into the first equation as my preference and calculate for c. It's -4. Over here, this is the proper and easiest way to get the both constant, the plus c and the variables of the k before you carry out integration. So this is the mystery way to solve it. Okay, please understand these statistics, the tackle of this question. All right, and keep practicing. I believe that you are able to answer this type of questions. Now, find the equation of the curve. Finally, rewrite the equation. So you can say EQ of the curve is what? Record it back. What you have integrated over here. Like like this. From here, what? Okay? Is y equals to the, what is k? 4. So 4 over 3 x cubed minus 6x squared plus 5x, and don't forget the minus 4. Voila! That is your final answer for the equation of the curve. So after I got this video, alright, hopefully you will say that Pure Maths 1 is the easiest subject among the other subjects that you have enrolled. Okay? So yeah, let's move on to the next question. Okay, here is the next question, which is the question 6. A curve is such as dy dx equals to the 5 over square root of 2x minus 3. Okay, let's write it first. Alright, given that the curve passes through the point 2, 1. Okay. So, after you integrate it, substitute the points given, which is the 2, 1 as the boundaries. P21. Okay. And hence, find the equation of the normal to the curve. So this is your basic fundamental concepts of differentiations. Okay. Like, how to get, first, determine the gradient of tangent first. Okay, using the points, what is the point? It's 2, 1, right? So substitute the 2 inside. So it's 2 times 2 minus 3, so it's 5. And remember that this is very important, that you should know that the gradient of tangent is perpendicular to the normal. It's because of tangent. This is the curve. Let's say, although it's not accurate, okay? So this is your gradient of tangent. This is your tangent slope. And I want to get normal. So this is normal. Tangent is perpendicular to normal or orthogonal. Alright? Therefore, gradient of t is multiplied by gradient of the normal equals to -1. Okay? Hopefully you understand the fact about this. Okay? So the gradient of normal is -1 over 5. Now you substitute the gradient ratio, which the point also lies on the normal curve. So it's y minus 1 divided by x minus 2 by using the proportional gradients. And hence simplify the expressions. Okay? So for me, I will leave in the gradient form, intercept form. Alright? Sorry, it's gradient form. Okay? Y equals to mx plus c. Eventually, you will get y equals to -1 over 5 plus 7 over 5 as your final answer for the equation of the normal. So this is your equation of normal. Basic math students must say that this question is very simple already. Okay, if not, you are not able to answer these typical basic questions. So let's move on to the part B. Find the equation of the curve. Alright, this is what I taught you just now, right? Integrate right now. Y equals to the integral of the 5 over 2x minus 3 square root dx. Okay, make sure that the integrals must be indefinite integral because we want to get the equation of the curve in terms of x, between y and x only. Alright? So how to integrate the following square root function? No worries that the inside function is linear. Okay. First thing first, copy this because its power is negative 1 over 2. After you integrate plus 1, you will get 1 over 2. And what is the constant beside the x, which is 2? So put divided by 2. And what is the power of the square root? It's 1 over 2. So you must divide the power. So what you can see over here, the 2 and the 1 over 2 can be cancelled out. And don't forget the plus c. Okay, the constant. Since the point is given, which is 2, 1. Okay, integrate and simplify, you will get 5 cert 2x minus 3 plus c. So given the point is 2, 1, okay, the expression can be expressed into 1 equals to the 5 times the cert 2 times 2 minus 3 plus c. Okay? And now, let's get the plus c. Let's get what's the constant c in real numbers. It is negative 4. Finally, rewrite the equation of the curve into y equals to 5 times square root of 2x minus 3 minus 4. So, this is your equation of the curve. Alright? So overall, this question, you must know how to utilize between the differentiation and integration and combine it both. Alright? At this, we will discuss the passive questions in my few subsequent videos. Alright? So now, let's move on to the next question. Alright, let's move on to the question 9. Okay, this is still under the course book questions. Alright? So we start from A. Differentiate these particular functions with, expression with respect to x. So we start from A. Okay? So how are we going to differentiate the following functions? So what you can see over here, this is the inside function with a bracket outside. Okay? Which this function, the entire function raises to the power of 8. So what we can do over here, you can either use chain rule or, yeah, this is literally the chain rule. Okay? So here's the quick trick that you should learn. Alright? First thing first, remain this function, copy over here, copy a bracket over here. Alright? Move to the underside. So what is the power? It's 8. Move down and multiply. 8 times this particular function and deduct the power by 1, which is 8 minus 1, which is 7. Okay. And don't forget, by following the chain rule, you must differentiate the inside function as well. Okay, which contains inside the multiplication. So what is the differentiation of the square root of x plus 3? Okay, obviously it's 1 over 2x. 1 over 2 square root of x. Okay, now you simplified it. What do we get? Okay, you will get 4 multiplied by square root of x plus 3 bracket to the power of 7 divided by the x. So that is your derivative of this particular function. Okay? Yeah, just like that. Done. Okay, B. Hence, find the integral of this following function. Okay, so what you can see over here, we must know the fact that different integration is the reverse process of differentiation, or we can call it as antiderivative. So take the integration, rewrite the integration inside your solution, and what you can compare over here, compared to the last part, you are missing 4, right? So multiply 4 at both denominator and numerator. So you will get it something like this. So what you can deduce over here, okay, the integral of this following function is exactly this one. Why? This function we have derived from A. So this is a derivative of this particular function. Means what? Means that you just substitute back this integral back inside to this expression. So basically for this question, you just need to use the substitution. This result comes from the part A that you have done. Okay? So rewrite here, you should get the final answer of 104 bracket to the power of 8. Inside is the square root of 3 plus 3. Yeah, that's all. Okay, so overallly, this question does not require you to know how to integrate the following functions. Okay? However, as the one of the calculus student, you should know the fact that integration is the reverse process of differentiation. Okay, this is what I'm trying to emphasize. Okay, hopefully you understand the fact of it. Alright? So now let's move on to the next question we discussed today. Alright, let's move on to the next question, which is the question 12. So before I begin the question 12, alright? Okay, so now, as we have discussed the questions related to integration is the reverse process of the differentiation. Okay? And next, the indefinite integral is actually the integral of the integrand, where the integrand is the gradient to get the original function. Just that why we need to consider the plus c is because of the boundaries, and we can't know where it locates, all right, unless the boundaries are given to you. Okay, so for this case, area of the each shaded region is the sum of the each strip by following the Riemann sum. But in A levels, you don't have to prove the Riemann sums to get the area of each shaded region. However, you should know how to grasp that area under the curve is actually the integration for the certain boundaries. So now let's start from A. Okay, A. So here is the region of the A in the cubic function. So obviously what you can see over here, it diagrammally illustrates the limits of 0 to 4. Okay, just find the shaded region. So what is the function? The curve function bounded between the curve and the x-axis. So it's actually the integration from 0 to 4. Now it's definite integral. That means you don't have to consider plus c already, as I have explained it further in the lectures just now. Okay? So you can write region R, but for me I write region R. You can also write the other variables, let's say the A, the B. Anyways, as long it doesn't matter. As long you are able to show that the integration is the area under the curve. So by stating the long S sign over here, write the correct limits for the correct integrand. So the integrand is the original function. So for AS level, you don't have to worry that um, you are going to integrate the other functions than the algebra or polynomial functions over here. Okay? In your AS examinations, you are going to learn how to integrate for polynomial function only. Okay? Because these advanced will be, you will learn in your next phase. So now, how to integrate this? X cubed, what you will get? It's the 1 over 4 x power 4. And 2 plus 1 is 3, so it's a negative 8 over 3 x cubed. 16x is the x to the power of 1. 1 plus 1, 2. 16 over 2, you will get 8. Okay, this is the expected result. No, this is exact result that you should obtain. Okay, now you substitute the limits inside. For me, I will write the full workings for your understanding. And for me, to save the time, I don't write for the zero boundaries already, because when you no matter how you substitute the zero inside each function, it has the dependent variable of x. So writing inside the working becomes meaningless for me. So now let's calculate the inside function over here. I mean the boundaries that have been substituted inside the function that we have integrated. So now, use your calculator to calculate it. Of course, each calculator has the integral function, but it only supports the definite integral. Okay? So you will get a weight. X power 4. Yeah. How can I get negative? Okay, let me try again. It starts from 0 to 4. And what the function that we tend to integrate is this function, right? Okay. 64 over 3. Oh, my bad. This should be the square, huh? My bad. Guys, sorry about it. Sorry about that. Okay, so it's actually the 1 over 4, 4 power, 4 power 4 minus 8 over 3 times the 4 to the power of 3 plus the 8 times 4 squared. You will get 64 over 3. Yeah, this region should give you the positive value. This positive scalar value is the area under the curve from 0 to 4 unit. Okay, so you are encouraged to write the unit square behind, even for the volume as well. Okay, so now for B, find the region of R over here from 1 to 3. Okay, so it should be simple. B, the region R for the B is the integral of this function from 1 to 3. Okay, locate the limits correctly. So what we will get? 2x plus 3 over x squared minus 1 dx. Okay, so you should get 1 plus 1, 2, so it's x squared. And this is negative x, because negative 2 plus 1 is negative 1 divided by negative 1, so it gives negative. Negative 1, it will be integrated into negative x, okay, from 1 to 3. Now substitute inside it, but since the lower limit is not 0, so no choice, I have to write it all for your understanding. Okay, so let's determine each limit one by one. Okay, 3 squared is 9, 3 over 3 is 1, and negative 3, this is 5. 1 square minus 3 minus 1, negative 3, so you get positive 3, which you will get the integer value of 8 unit for the region R at B, part B. Okay, so I think it's easy for you, and to save our time, I will let you to try the part D by yourself. Okay, so if you are able to find the area of this region for part D, comment in the description below. Okay, and if you, as the same as the past, if you have any questions, just reach out to me without hesitation. All right, now let's move on to the part C. Okay, y equals to x times x minus 5. So usually for this in your syllabus, you are going to expand inside it all in order to integrate it easily for you. Okay? And you are not encouraged to use the A2 syllabus, which is the integration by parts. You will learn in A2. Please follow my subsequent videos. All right? So to get the region R for C is the but remember that area is not negative. How should we do? Either you can switch the limit sign by writing like this, 5, 0. Okay, as we know that following by the integration rule, AB is equal to the negative BA. But for this, I'm not encouraging you to write in this way. So instead, following my personal experience, just put the modulus instead. Okay, from 0 to 5. As we know that this area we are trying to find is actually giving the negative value or the areas for the negative in the negative region. Okay, so x times x minus 5, you will get x squared minus 5x, obviously. Now integrate it. You will get 1 over 3 x power 3 negative 5 over 2 x squared from 0 to 5. And we should expect that this evaluation gives a negative value. After that, we take the absolute value to get the positive. Okay? So this is for part C. Okay, I may skip the steps in the middle and I just give you the answer directly. So by right, this evaluation should be easy. You will get negative 125 divided by 6 for the inside function. And after you take the modulus, you must get a positive. So it's 125 divided by 6 unit squared. That's all. Okay? And as I said earlier, question D, please try out by yourself. Comment your answers in the description below. And also, I will check your answer one by one. And of course, I will ask you how you perform your workings to get the answer you have comment. Okay? So see how much you understand after reviewing this video from the lectures just now. Okay? So yeah, let's move on to the next question, shall we? Okay, next question. Wow, we came here so far. So this is the area of the shaded region with the both functions bounded. I mean the both graphs bounded. So usually what you can see over here, the both graphs have two intersection points. So when it comes to two intersection points, you must think about the simultaneous equation. Okay? So imply the first function, this is your equation 1. Another is the equation 2. Okay? Substitute the first equation into the second equation. Okay, you will get this 2x plus, what is it inside? This one, right? It's a negative 5, and negative x squared plus 11x minus 18 equals to 18. Okay, now let's deduce it quickly. Negative x, move to the other side, you'll get x squared. 2 plus 11 is 13, negative 13. And here's the constant value on the right hand side, 12. So you move to the right hand side, you will get the plus 30. Now solve the quadratic equation over here. Okay, you will get x equals to 3 and 10. So means what? The x coordinate for the both intersection point is 3 and 10 positive. So obviously, apparently, the x coordinate of A is 3 because it is placed on the left hand side. So x coordinate for the B will be the 10, which is on the right hand side. So now, I want to find the x coordinate at this, referring to this line, because this line is dependent. So what is it? It is a x-intercept. Okay? So you say when y equals to 0 for the function, for the linear function, 2x plus 0 is equal to 12. Therefore, the x coordinate for this point is 6, which means that this is 6. Okay. So later on, what are you trying to integrate is this area of this region only. So we have to separate one by one. Okay, for the first one, it is integrate this region, integrate the function of this from 3 to 6 to get this region, minus away this right angled triangle. But of course, you may integrate this, but for me, I will use the basic triangle formula, which is the half times the base, which is 6 minus 3 to get 3. Oh yeah. Yeah, of course, you should find the height for this triangle. So you can say when x equals to 3 for the linear function, what will you get? You will get 6. So which means that the height is 6. Okay? So the area of this triangle, the integral of this linear function from 3 to 6, 12 minus 2x, apparently it is equal to the half times 3 times 6. Okay? Half. Of course, we can try to integrate that. This is 12x and the x squared. You can try to substitute and see. You should get the same value. Okay? But we don't have to do that because it's kind of wasting our time. So, let me name this as region 1, region 2, and region 3. Okay? So, let's start from region 1. Okay, how to get the region 1? Region 1 is the integral from 3 to 6, okay, when the integrand is the quadratic function, dx minus the area of triangle, which is the half times 3 times 6. So now we evaluate the integrals inside here first, which is negative 1 over 3 x cubed plus 11 over 2x squared minus 18x from 3 to 6. And this one you can cancel out to get the 3. 3 times 3, negative 9. So negative 9. So to save our time, I'll calculate the definite integrals with the limits given directly. So what we will get is the, let me see. Okay, you will get the 63 over 2. Don't happy too fast because this question hasn't ended yet. Okay, the first region you will get 45 over 2 units squared. Region 1 only, okay? Region 2 you may rest assured because you are getting the area for the positive region, which is bounded between x equals to 6, x-axis, and the quadratic curve. So it's region 2 equals to the integral of the quadratic function from 6 to 10. Okay? This gives negative 1 over 3 x cubed plus 11 over 2 x squared minus 18x from 6 to 10. Okay? So you may use your calculator, just that you need to change the limits. So region 2, you will get 56 over 3 unit squared. Okay, for the region 3, it's actually bounded by the straight line and the curve and also the x-axis. So which is the biggest? Apparently, it's the right angular triangle. So now let's get the area of the triangle, which is half times 10 minus 6 is 4, multiplied by, you should get the y coordinate for b. Okay, so we can say that when x equals to 10, okay, just substitute inside the linear function to save your time. It's negative 8. So which means that the y coordinate of the b is 8. Negative 8. So which means that the height is 8 and the width is the base is the 4. So the area of the largest or the right angle triangle is half times 8 times 4. Okay? Half times 8 times 4 minus oh yeah, we forgot to find the roots of the quadratic function over here. So now let's solve it now. Just press your calculators because the marks may not be considered of you to find the intersection points. Okay, mostly the marks are allocated for the integrals only. All right. So just solve the quadratic equation for the quadratic function. I mean the quadratic function for this curve. Okay, the roots are x equals to 9 and 2. So we should take the bigger ones to make it sensible. So this is 9 for sure. Okay, which means that we have to integrate the quadratic function from 9 to 10. This gives a negative value or the negative area for this region. Okay, so I should put a modulus for the integrals of this quadratic function from 9 to 10. This one we can cancel out. This is 16 minus, yeah, just integrate it directly. So for me, I'll press calculator to save our time from 9 to 10. So of course, it gives you the negative value of the negative 23 over 6. Okay. So you will get 73 over 6 for the unit square for the region 3. So now it's time for us to find the area under the curve, area of the shaded region over here. So just sum up the R1, R2, and R3. Okay? So R will be the total area of the shaded region. Okay, which is 45 over 2 plus 56 over 3 plus 73 over 6. What will we get? Okay, you will get 160 over 3 units squared as your final answer. If you want to round, if you want to leave in decimal place, please do so. But make sure you obey the standard non-exact answers. Okay, which is implied in your instruction paper for the external exam. So by right, you should put in 3 significant figures only, which is the 53.3. All right. Okay, that is the end of this question. So if you have any problem related to this question, please ask it so. Alright? So now let's move on to the next question. Alright, let's move on to the next question, which is the question 18. Okay, this question is related to the volume obtained. Okay, which is rotated through the 360 degree about the y-axis, which it rotates like this. So if the region rotates about the x-axis, it rotates in this way. So what you can see over here, each pieces is a disk. This is a circle. Okay? So like the previous question, it rotates through the x-axis, which it rotates like this. My bad, it's actually like this. So to get the volume of the shaded region through the about the x-axis, which is actually through the 360 degree, is actually the V equals to, don't forget the pi, the regions times y square times dx. Okay, y. Pi y square is actually the area of the circle, where the radius is the y, and y should be squared. Okay, and what about the height? The height is actually the sum of the change of the x from the given interval. Okay, as I have derived this formula earlier. So conversely, for the y region, v rotated through 360 degree about the y-axis is equal to pi from the certain region x square dy. Why? X square is x is our radius already, and pi, okay, is the circumference or the pi. To get the area of the disk, dy is the width, and the sum of width of dy from the given interval is the height. Okay, to get the volumes, like we are determining the cylinder, but this time it's not cylinder because the curve is not constant. I mean non-linear. So now, by using this formula stated over here, okay, we find for the question 18. Okay, A. Now, this is the volume of the shaded region rotated about the y-axis. So which means that we should get rid away the variable x. Alright? So let's operate it here. You will get the x squared equals to y minus 2. So which means that when it comes to the square of the x, you don't have to do the extra working. Okay? Isn't it convenient, right? So the volume of the shaded region starts from 2 to 11, where these limits are referring to the y values. Okay? Pi x squared this dy. Pi is the constant. You may put it outside. And x squared is the y minus 2. And then dy. Integrate it. It's easy. Okay? Now, use your calculator to calculate it. Okay, for me, I'm able to calculate it. (58.5 to y. 11 minus 2 minus times the negative 2, negative 18. Okay, the answer goes to 40.5 pi unit cube. But if you want to calculate it until it becomes a decimal form, yeah, please do so. But make sure you follow the standard non-exact value answers procedures. Okay? The rules that you should obey. Okay, it's 127 only. Like this. Okay, because we have to obey that your answer in non-exact is 3 significant figures only. Okay, so that's the final answer. Okay, for the B, I want you to try out by yourself. Okay, if you have any questions, just feel free to ask me without hesitations. Okay, so we have ended the discussion for this question. Now let's move on to the next question. All right, let's move on to the next question, which is the question 20. Okay, so this question is under the course book question as well. So look at the diagram. All right, the diagram shows the part of the curve of this particular equation shown over here. And now show that as p goes to infinity, the shaded area tends to the value of 2. So this question is related to the improper integrals, which involves the limits of the continuity. So how does it perform? All right. So please look through this tutorial carefully. Okay. So as you know that what you have learned is this area of the shaded region relates to integration, correct? But we can't know the definite limits from the lower side, or it's an undefined lower limits. Okay? So this lower limit is actually the oh my bad, because it is defined when the x equals to 0. So we start from 0, but the upper limit we can't know. All right. So area is the A. Okay, you can put R, but for this question I put A for your understandings. Is equal to the integration. It's a definite integral. Okay, that is the area under the curve. Starts from 0 to infinity. Okay. So let me write all the integral full completely first, respect to the x. Okay, so what you can see over here inside this integral expression, okay, of course the integrand is the original function, and we can't solve this improper integral directly, but instead what you can do is to use the limits. Alright? So here's the step. Substitute the limit as any one of the variable you like. It's up to you. Alright? Put the limit lim is not the surname, okay? So put any variables. For me, I will put a tends to let's follow this question, alright? So let us put p instead of infinity. Okay, so which means that after you solve this integral and the limit substitutions, you may take the limits as p goes to infinity. Alright? So you should write it like this. Okay, that's proper. Now you make the inside integral be a proper integral. It seems to be like the proper integral, but eventually you still have to consider the limits over here as p goes to infinity. Okay, obey the questions given. Now solve the integral inside here. So how you integrate this? It is the 2 in the reciprocal. So if you change it by the indices, it's -2. Okay. So it's a 20 -1. Okay, it's actually the divided by -1, but we just put negative. And don't forget to get the 2, which is -20 divided by 2, 2x plus 5. Okay, that is our integral. Okay. So this one we can cancel out. Okay, so by right, we should get this kind of the simplified expression for the integrals. Now substitute the limits given. Okay, after the both limits have been substituted inside the expression, you will get something like this. Okay, so why is 2? Okay, because 2 times 0 is 0, 10 over 5 is -2, but following is a lower limits, negative gives positive. Okay, so yeah. Now take the limits. Okay. So looking at these two expressions, what you can see over here, there is a constant of 2, which is not affected by the limits because there's no p. It's independent from the variable p. So we just take over. We just let it pass. Alright? So let's consider about this only. Okay. So as p goes to infinity, we can try to think about what is the reciprocal of the p. So what you can see over here, the numerator gets bigger and bigger until infinite, which means that the bigger the value of p, the smaller the value of its reciprocal. Right? So as p goes to infinity, its reciprocal is approaching 0. Okay? So which means that this entirely this expression, after its limit is taken, it becomes 0. So the answer goes to 2. Shown. Okay? So at this stage, you have successfully proved that the limits, the area, the shaded area, as the upper limits goes to infinity, no matter how much the p goes, you will get 2. Okay? Accurately, it can be 2.00000 and something. But we just consider about the 2 only. Alright? And many of you are curious that why I can let this equal to 0 after its limit is taken. Okay. So this is a constant, right? And here is the linear functions in the denominator. So its fundamental is you divide everyone by p. Okay? Which means that no variable p which has the power of 1. Okay? At most, the power is 0. So, yeah, times 1 over p at both sides. You will get 10 over p, and this you will get 2. So that this expression will be defined. So now it's time for us to substitute the 1 over p is 0 for this one and this one. So what you can see over here, despite this is 0, however, the denominator isn't the 0 because there's a 2 over there. So which means that this number is defined. Alright? No worries about that. Okay? So, at this, for your understanding, I have proved the correct mathematical the logical reasonings over here. Okay? So yeah, this is how you deal with the questions when it comes to the improper integrals inside the area calculations. I mean the area under the curve. Alright? So I believe, not believe, because this question I made is made by me. So this question will be the last question of the course book questions before the challenge segment. So yeah, let's move on to the next question. All right. Here it comes to the challenge segment. The first question of the challenge segment we discussed on today. So this is the question 22. It's still under the course book, same pattern as the past. All right. So look at this question. The tangent to the curve y equals to 8x minus x squared. So it's the quadratic equation, okay, the parabola curve at the point 2, 12. Okay, let me plot the point 2, 12. So what you can see over here, here is the tangent which has a slope from the x-axis, okay, where it cuts the x-axis at the point P. Now find the coordinates of P. So when we are trying to get the gradient of this slope, of this tangent, what can we relate? Okay, take a look at the equation. All right. Y equals to 8x minus x squared. So by using the definitions, obviously it is dy dx. So dy dx is the gradient of the tangent. All right. So differentiate it now. You will get 8 minus 2x. Now, what is the x coordinate at this point? It's 2, right? So substitute x equals 2 inside the gradient function that we have differentiated. So it's 4. Okay, the gradient of the tangent is 4. Now, use the gradient proportionality. Y minus 2. Y minus 2. Y minus 12 over x minus 2. Okay, that's the gradient proportionality because the ratio is the proportion. Now you may construct the equation, but for here, I may construct into, express and simplify into a gradient form. Gradient form, which is in the form of y equals to mx plus c. Okay, here it is. So this is the equation of the tangent, this slope at 2, 1, 2, 12. Okay, find the coordinates of P. So what is the coordinates of P? Given that the y coordinate is 0 for sure, obviously. So it's xp 0. So which means that when y equals to 0, substitute the y equals to 0 inside the equation that we have derived. Now find for x. So x is negative 1. Then, in your answer, please imply the full coordinates of the P. okay, in order you to get the higher marks or and even full marks. So the P coordinate is -1, 0. So that's the final answer. Okay. And then it's time for us to find the area of the shaded region. Okay. So you have several methods that you can use, but for me, I'll use the quickest way. The most essential element is save time, time saving. Okay. B, find the area of shaded region. Okay, the area of this region. All right. So first, let's look at the triangle over here. All right. Okay, before we start calculating, you have met several approaches. One, find the area of this right angle triangle, and then the area of the trapezium minus the area under the quadratic curve. Then you find the area of the quadratic curve for these intervals from 2 to 8. Okay? But I tend to follow the alternative methods, which is find the area of this triangle first, then the trapezium, minus the area under the curve from 0 to 2, and then the area under the quadratic curve from 2 to 8. Alright? So this is how I think. Okay. Write a big A that represents the area of shaded region. So this is -1 just now. Y-intercept for the equation is 4, which means that the height is 4. And this is 12. So it's the half times the 1. Okay? So in area, we don't consider negative value. It's all positive. So this is the area of the first triangle. Next is the area of the trapezium. Half times, what is the height? Is 2. 12 plus 4. Okay, make a square bracket minus the area under the curve, which is the integration from 0 to 2. 8x minus x squared dx. So it's oh my bad. It's actually all will be included. So we just find the area of the trapezium. Yeah. Yeah, because I thought we are going to find this region only, but in fact, it's actually the area of the entire trapezium. Okay. Third one is the area under the curve. What is it? It's the integration of the 8x minus x squared from 2 to 8. So please locate the limits correctly for the certain area of the shaded region. Okay. So this will be the alternative way for the area under the curve, the calculation of the area. Okay. Let me move to the next page. Right here. Okay. Now integrate it. This is 2. This is 16. Oh, I forgot to put the dx, my bad. So it's 4x squared minus 1 over 3 x cubed from 2 to 8. So this is 18. Okay. Substitute the boundaries given, I mean the correct limits over here. And now use your calculator to calculate the areas that gives the final answer. Okay. It's the 18 plus 72. So your final answer is an integer. It's 90 units squared as your final answer for the area of the shaded region. Okay? So this is how you solve the area under the curve with the application with the differentiation. Of course, you need to master how the differentiation relates to the integration. Okay? Hopefully you understand about this. Okay? So yeah, let's move on to the next question. Alright guys, so the question just now is actually the last question before the passive questions. Welcome to the last chapter. The partial discussion for the last chapter, which is the integration. So this is question 29 from 9709, October, November 2004. Question 7 from paper 1. Okay? So this question is related to the gradient. To get the original equation of the curve, you must use the gradient function to integrate it. Okay? So given the dy dx is equal to 6 over square root of the 4x minus 3, and P33 is the boundary given. Now find the equation of the curve. So it's actually y equals to the integral from to get the equation of the curve, it is an indefinite integral. So your integral should write it like this. Now integrate it. What do we get? You will get 6 times the square root of 4x minus 3. Okay, divided by 1 over 2 times 2 and divided by 4 plus c. Why we should plus c? Because it's an indefinite integral. Okay? So it's y equals to 3 square root of 4x minus 3 plus c. Now, we can say when x equals to 3, y equals to 3. Okay, these boundaries are given for you to find the c, the constant that you have put. Okay? So use your calculator to calculate it. Okay, the c is negative 6. It's a constant. And then the question demands you to find the equation of the curve. So you should give the final answer of the equation of the curve in the correct form. So it's usually I'll put it as, or everyone put it as y equals to 3 times square root of the 4x minus 3 minus 6. So that's the final answer of the equation of the curve. Pretty simple, right? So you have no excuse to say that calculus is difficult, because the more toughs are coming to you. Okay, when you tend to pursue the engineering degree studies. All right. So yeah, we have ended this question. Let's move on to the next question. All right, let's move on to the next question, which is the question 33. Okay, so this question is a past questions from 9709, May, June 2010, question 5 from paper 13. Okay. So this question is also related to the equation of the curve with the concept of the indefinite integral. Okay. Now find the equation of the normal. Of course, dy dx gives represents the gradient of tangent, right? So this is the gradient of tangent. And we want to find the equation of the normal. So first thing first, substitute the boundary points. Okay, get the x coordinate from P is 2. So substitute the 2 inside the gradient function. dy dx is equal to the gradient of tangent 6 over square root of 3 times 2 minus 2. Okay, it's 6 over 2, which is 3. Okay, so what is the relationship between the gradient of the tangent and the... what's the relationship of the tangent and the normal line? They are perpendicular to each other, right? So because normal denotes perpendicular or orthogonal. Okay? So gradient of tangent multiplied by the gradient of the normal gives you the -1 because tangent and normal are perpendicular to each other. Gradient is 3 mn. Okay, the gradient of normal is -1 over 3. Now, use the gradient proportionality. Okay, so even it is in normal, the points are common. Okay, so it's a y minus 11 divided by x minus 2. Okay, for me, I feel like the intersection form is preferable for me. Okay, so now multiply the x minus 2 to the right hand side. Okay, now simplify it. You will get y equals to -1 over 3x plus 35 over 5. So this is the equation of the normal to the curve at point P. That's one of the final answer. Or other equivalent equation which is accepted by the standard marking scheme of the Cambridge A-level. Okay? Or you can write it in the standard form. It's up to you. You can write it like this. 3y plus x is equal to the 35. It's also acceptable as long these two equations are equivalent to each other. Okay? So what you can see over here, this past year questions aims for you to master the concepts of the calculus, which is the basic differentiation and integration over here. Okay, second, find the equation of the curve. So how to get the original equation of the curve? What you can think is indefinite integral and plus c. When you think about plus c, what is it? Boundaries, right? So here is my set, gradient, see the keyword, equation of something. Usually it prompts you the curve. So what you should think? Integration lah. Integration of gradient, that's all. Okay, it's the sum of the area. And after no limits, you should think integrate plus c. Plus c, what you can think? Boundaries. Boundaries, what can you think? Coordinates, right? Coordinates, what you can think? Substitution, right? Substitution, what you can think? Find the c. After you find the c, what should you do? Is to rewrite the equation of curve. That's all. Is it difficult, right? Is it difficult? No. Okay? Please think it easier. Alright? So, dy dx is equal to the 6 over square root of the 3x minus 2. Now, let's carry out the integration. Okay? Remember, equation of the curve does not involve limits inside the integral expression. Okay? So this is the square root. Okay? But I feel like it's preferable to write it in the power form, index form, right? Which is -1 over 2. for your understandings. Now, what's next? Plus 1 for the power and divided by the power. So it's the 2 times 6 divided by times 1 over 3, 3x minus 2, 1 over 2 plus c. Okay, this one cancel as 2. So rewrite in the neat form, which will give you like this. Okay, plus c. What's next? Boundaries. Where is the boundary? Here, right? P to 11. What's it? What is it? What it gives you? The x coordinate and the y coordinates, right? Yeah, just substitute. Just substitute inside to get the c. Easy. Okay? So this is 11 is equal to the 4 square root of 3 times 2 minus 2 plus c. What is the c? 3 times 2 is 6 minus 2 is 4. So this value gives you 4. Square root of 4, you get 2. So 4 times 2 is 8. 11 minus 8, you will get a 3. Positive 3. So you have C already. What's the final touch? Rewrite the equation, right? So because the question demands you to find the equation of the curve. Okay? So you can write it over here. It's optional for you to write the statement, but it's best to explicitly leave your final answers so the examiner can able to understand. So it's a y equals to the 4 times the square root of the 3x minus 2. What's the c you found? The 3. Positive 3. Yeah, that's all. Okay? So, as I said, practice makes perfect. Alright? So, yeah, let's move on to the next passing questions. Alright, let's move on to the next question, which is the question 36. So, this question is also the passing questions from 9709, October, November 2005. Question 10 from paper 1. Okay, this passage is quite early. Okay, a curve is such that the dy dx is equal to the 16 over x cubed. So this is the gradient function for sure. And the 1,4 is the point on the curve. So which means that the 1,4 meets the point, meets the curve. This is called boundary. This is called grad of tangent. Okay, so what is the equation of the curve? As I have taught you just now. Steps. What's the steps? 1. Integral. 2. No limits, right? Plus c. Plus c, then what? Boundary. Then what? The values of c is what? Finally, what is it? What is it? Equation of the curve. So follow these 5 steps I teach you over here. Okay, step 1, integration. Integration of what? This gradient, respect to the x, so dx. Y equals to integral of the 16 over x cubed dx. Okay, no limits are written. Okay, on above and below of the long s sign. Okay, x cubed, we can write it as 16x power negative 3. So, negative 3 plus 1, negative 2, 16 over negative 2, which you will get, maybe I write it over here. 16 over negative 2, x negative 2 plus c. Okay, I highlight over here, plus c. So 16 over negative 2, which you will get, what? Negative 8. Okay, for me, I write it back. Plus c. You see? Yeah, until here, you at least got marks. Because for this kind of question, it is worth 4 marks, you know? So it's hard for me to get the 0 marks for this question. At least you are able to integrate the following functions, because all of the functions in AS syllabus, pure mathematics, is all algebra or polynomial equation. Okay? So this is it. Now, next, what's next? Boundaries, right? Boundaries, where is the boundaries? The points. 1, 4. X and the Y. X equals to 1, Y equals to 4. What's next? 4. Okay, this is 4. Equals to the negative 8 divided by 1. Okay, 1 squared plus C. Obviously, this is 8. 8 plus 4 is you get 12. Okay, 4, or in American way, is the plus 8 at both sides. And this one cancel, and this one add up to get the 12. What's the final touch for this part? Equation of the curve. Just rewrite it. Copy this, then what's the plus C? The value you found. The C value you found. So y equals to negative 8 over x squared plus 12. That's all. Okay? And now for the question 3. Okay. So this question is also related to integration. Just that you have to integrate this. Not the gradient function. Okay? What it wants is the area under the curve, which is related to the original equation of curve. Okay? So the area of the region, region enclosed by the curve, x-axis, and the lines 1, 2. Okay. So until here, you don't have to do any actions, and not even to draw the graph, because it is a significant time consumption. So instead, we just integrate it, will do. What's the limits? From 1 to 2, right? Okay, put the 2, put the 1 and 2 in the top and bottom right corner of the long S sign. And then the equation of the curve that we have found over here. And then integrate it. What we get? This is negative 1, so it's a 8 over x. This is 12x from 1 to 2. Then you substitute it. Okay, so the final answer for the area under the curve is 8 units square. Okay, please verify your answer once again. Okay, so yeah, this question is quite direct. So now let's move on to the next passage questions. Alright, let's move on to the next question, which is the question 39. Okay, this question is also the passage questions from 9709, October, November 2007, question 2 from paper 1. Okay. Find the area of the region enclosed by the curve y equals to 2 square root of 2, the x-axis, and the lines x equals to 1 and x equals to 4. Okay, so over here, obviously, this is a square root graph or the y square graph. Okay, there's a stretch of the 2, which means its vertical stretch increases by the factor of 2. So it's optional for you to sketch the graph, but by my preference is I don't sketch the graph, but for your understanding, I'll sketch it, will do. So this is how your square root graph looks like. Okay, y equals to 2 times square root of x, start from 0. But for the x value, it only defines for the positive x-axis. This is the definition for the square root function. And the x-axis, yeah, this is the x-axis. X equals to 1. Let's say this is 1, alright? Okay, let me draw a vertical line. But in fact, you don't have to draw the graph if you are able to understand what, or imagine what's the area of the shaded region that you want to find by using the integration for sure. Okay. So here's the x equals to 4, if let's say. So that's the 4. Okay. So actually, the question wants you to find the area of this region from 1 to 4. Okay? This is the area that we want to find. So to find the area, we use integration. What's the limit? 1 to 4, obviously. But without referring to the graph, we can automatically imagine that the graph is a positive graph, starts from origin. And then what's the limit? 1 to 4. Okay? You can try to imagine by yourself without referring to this graph that I have drawn over here. Alright? Yeah, just like this. Okay, how to integrate the square root function? So it's easy one, because eventually it's an polynomial function to be integrated as the integrand. So we will integrate this integrand into 2 times x to the power of the 3 over 2 divided by 3 over 2, which is 2 over 3, and then 4, 1. 2 times 2 is 4 divided by 3, x 3 over 2. So that's the integrated result. Now substitute the limits inside to get the scalar value of the area. So just put it inside. Okay, here is it. Here it is. 4 over 3. Okay, the 4 square root of 4 is 2. 2 is 8 minus the 4 over 3. Okay, you will get 28 over 3 unit square as the final answer for the area of this region. Okay, pretty simple, right? Now, let's move on to the next question. Alright, let's move on to the next question, which is the question 42. So this question is also from the past questions from 9709, October, November 2009, question 4 from paper 11. Okay, so there's the equation of the y equals to the x power 4 plus 4x plus 9. Okay, it's a quadratic function. So quadratic function is actually out of syllabus. Instead, it can be classified as the polynomial function. Alright, so it's hard for you to draw the graph diagrammatically. So think about, you see, when x equals to 0, it is a positive, right? If you substitute the x equals to 1 inside, this is 1, this is 1, positive 1, positive 1. So which means that everything is positive. Means 1. This interval between 0 to 1, it's always positive. Okay? So for x from 0 to 1, okay, or even the equal sign, the y is always positive for sure. Okay? Because there's a plus 9 over there. So we can imagine what's the area of the shaded region looks like. So we don't have to draw the graph, because for me, I don't prefer to draw the graph. It's kind of waste time. Now integrate it. Okay, you will integrate into 1 over 5 x power 5 plus 2x squared plus 9x from 0 to 1. Now substitute it. Okay, for this, because each term is dependent on the x, that means for the 0 limits, we can cancel out each other, because since the multiplication of each term will get 0. So you will get a positive answer, which is the 56 over 5 unit square as the final answer for the area of the shaded region. Okay? So yeah, let's move on to the next question. Alright, let's move on to the next question, which is the question 46. So this question is from the past questions from 9709, October, November 2003, question 9 from paper 1. Okay. So here's the diagram, and the question is regarding the volume of the solid form over here. When this solid, I mean the shaded region, is rotated completely means 360 degree about the x-axis, which is the 8 pi. Okay, the question wants you to show that the volume of the solid form is 8 pi. When it is rotated 360 degree about the x-axis. Well, right? So for this, you are required to use the formula of the volume with the integral term. So here's the thing. V equals to the integration, because it is the axis is in x-axis, so we have to depend, the limits must depend on the x values bounded, or the x values, the limits of x involved. So the limits of x involved is from 0 to 2, obviously, and there's a pi times y squared. Why the y squared is actually the radius of each point. Okay, each of the radius of the disk is different depending on the y respect to x. So it's a y squared and dx. So dx represents the height, and eventually we have to sum up the every height. And y, of course, is a different. So as we know that integration is a sum. So here's the formula. All right. Now, Now we are looking for the y squared. Okay. Of course, we have the y equals to the 8 over 3x plus 2 squared at both sides. We will get 64 3x plus 2 bracket square. Just remain it, okay, to avoid confusion. Alright, and now substitute inside the volume formula. Okay, so it's the V equals to the integral of the pi times the 64 divided by 3x plus 2 bracket square and bracket dx from 0 to 2. And pi is the constant, we put it up. Okay, because it does not involve the integral, because there's no x. And integrate it now. It's the pi. This is negative 2. Negative 2 plus 1 is a negative 1. So we must put a negative. And there's a 3. 64 divided by 3 is 64 divided by 3. So it's a negative 64 divided by 3 times 3x plus 2. Okay, 2, 0. Okay, now pi, if outside bracket or the braces bracket, minus 64. Okay, now we substitute the boundaries. Okay, because there is negative, you see that the reciprocal for the first limit is way higher than the second one. With the lower limit, I mean, that means this value will be higher, of course, because of the smaller value of the the denominator. Okay. So when it comes to the calculation, not only to have a good observation, you must have a good prediction. Like if you tend to become a statistician, all right? 3 times 2 is 6. 6 plus 2, you get 8. Plus the 64 divided by 3 times 2, which is 6. Okay, you will get 8. So, you see, you will get the 8 pi, where the coefficient of the pi is 8, integer. So, look back at your questions, what it wants. Show that the volume of the solid form is 8 pi. Okay, therefore, shown. At this stage, you are success. you have successfully shown that the workings that you have done leads to the answer of 8 pi as uh, as the answer stated in the questions. Okay? So yeah, this question wants you to use this formula and the modification and then the workings that leads to the answer expected from the question. Okay, so yeah, let's move on to the next question, shall we? Alright, let's move on to the next question, which is the second last of the question among our discussion today, which is the question 51. This is the past questions from 9709, October, November, series 2010, question 11 from paper 11. Guys, keep going. Alright, 2 questions to go. Alright, okay. The equation of the curve is y equals to 9 over 2 minus x. Okay. Find an expression for the dy dx and determine with the reason whether the curve has any stationary points. Okay. Before we begin this question, dy dx represents what? You differentiate this function respect to x. And why the question asks you like this? Reason whether the curve has any stationary point. So, when it comes to stationary point, we must know that or to relate that the dy dx will be equate to 0. Okay? So that means you have to determine whether this equation is defined or not, or has the solution or not. Okay? So let's begin. First part, y equals to 9 minus 2 minus x dy dx is to take the first derivative, or you differentiate it once. What will we get? It's a negative 9 2 minus x squared. Okay, that's the one of the answer in this part. And now equate it to 0. When dy dx equals to 0, you will see that there's a negative. Okay, so what you can see over here, actually it is not defined or undefined. Despite the negative disappears here, but still it's undefined. Why? It's because of because you see there's a 9 in the numerator, and what you can see, the numerator is always positive. Okay? So we assume that for x are all real numbers, this entire value won't be 0. Maybe it can be 0 point something something like that. Alright? So you can say no solution. Okay? What's the reason? Just write 2 minus x bracket square is always positive. This is the first reason. And the second reason is the denominator cannot be 0 for sure. So therefore, curve does not have any stationary points. Okay, that's it for the part 1. Now, for part 2. Find the volume obtained when the region bounded by the curve, coordinate axis, and the line x equals to 1 is rotated through 360 degrees about the x-axis. So it must be rotating through the x-axis for the each disk. Okay? So what is it? This is a rational function, right? So for the rational function, its graph must appear a two parabola. It's not a parabola, it's a like a two curve, right? Or the two catapult, right? So x equals to 1 is actually maybe this side. Okay? But since there is a two position, which means that the asymptote will be different, which means the curve for the upper part will be intersecting the y-axis. Okay? So what we can do over here is to assume that it intersects with the curve. Coordinate axis means the xy axis and the line equals to 1. Okay? So the graph should look like this. This is what we can assume over here, and where this is the function of the function given. And we want to find the volume rotated like this. So this is the volume we tend to find. Okay? So volume is equal to the integral of the from 0 to 1 pi, because we want to because the volume consists of the area of the circle or area of the disk. Y square times dx. Sum of the dx is the sum of the height of each disk. Okay? For the certain limits. Okay, what is the y square? Let's determine it fast, which is 81 divided by 2x minus x bracket squared. Like this. Take it out, we find the volume. So until this step, you are able to get at least 2 marks. Why? First, you imply the formula, then you substitute inside 1 mark, square it up until you get this form, another 1 mark. Integrate 1 mark, limit 1 mark, and the 1 mark for the final answer. Okay? Of course, each mark has its unique criteria. So yeah, integrate it, we will get the -2 plus 1, which is -1. So we put negative over here. 81. Oh, we have to consider it is actually the reverse chain rule. So I have to multiply x again. That means there's no negative over here. Okay? So substitute the limits inside. Maybe I write it neat and nice. Okay? There we go. So it's a 81 minus the 81 over 2. So your answer should be your answer for the volume is 81 over 2 pi unit cube as your final answer. Okay? Or in decimal, to be precise, you can write into because this is not exact value, so the answer accepted is 127 unit cube in 3 significant figures, according to the standard answers required by the Cambridge A-levels examination. Okay? So this is how you deal with the volume without referring to the graph. But you must have a good imagination. Okay? Okay, let's move on to the third part. Find the sets of the values of k for which the line y equals to x plus k is a linear line, intersects the curve at 2 distinct points. 2 distinct points. Please highlight it. What does it mean? This chapter is our first chapter. Okay? You should have to know it. It is actually b squared minus 4ac is more than 0. Set of values means it's actually the inequalities for the k in terms of k. Alright? So what can you do over here? First, you have the curve equation. you have a linear equation. Okay, first equation and the second equation equate to together. So what you can see, of course, it's 100% a quadratic equation, which raises to the power of 2. Expand and simplify into the general form, and then take the discriminant, which is greater than 0, not equal to 0. Okay, so it's a 2x x negative x squared plus 2k x squared. Arrange it into the general form. K minus 2 x and 9 minus 2k is equal to 0. So this is your general form over here. Now, when there is a two distinct point, distinct means different, okay? Or two distinct solutions, two distinct roots, apply b squared minus 4ac greater than 0, not without the equal sign. Okay? So if I'm the examiner, if I see you put the equal sign inside the inequality, no marks for you, because you didn't obey the questions or you didn't understand what the question says. Okay? So the b is k minus 2 bracket square minus 4, a is 1, c is 9 minus 2k. A, B, C is A is 1. Okay? So what you can see over here, once you will get the quadratic equation again. It's a k square minus 4k plus 4, and this you will get negative 36 plus 8. Okay, rearrange it, sort and simplify. Okay, so check whether this quadratic equation has the solution or not by pressing your calculators. Okay, it does have. So you can factorize into k minus 4 and k plus 8. When this equation is equal to 0, now you can use the graph sketching method or the line diagram, but I'm well encouraging you to sketch a quadratic graph. Remember, it's a smiley face, which it is the positive quadratic. Okay, the positive graph. Negative 8 and 4. And when it is greater than 0 means what? We are taking the range, the sets of values under the graph over here. So this is our range of the values. Okay? Therefore, the set of the answers is k is less than negative 8 and k is greater than 4. That's our final answer for the set of values. Okay? So hopefully you can understand about this, because this chapter is actually from our Pure Mathematics 1, Chapter 1. Okay? So yeah, let's move on to the next question, which is the last question. Alright guys, this is our last question among the integration chapter. So this is actually the extra questions for the improper integrals. Okay? Although this part or this subtopic doesn't seem to come out frequently, but we still have to discuss about this. Okay? So every student, you still have to master about the improper integrals. Okay? Somehow it may be applicable to your future studies. Alright? So this is the question 54, which is the last question among our discussion today. And let's start. Let's get started. So first part, find in terms of a the value of the of this integral where a is the constant greater than 1. Okay, for the a is greater than 1. So let's find the integral. 6x minus 2 to the power of negative 2, and then just copy it. Okay, so what you can see over here, this is actually the okay, just integrate it because I think I'm overthinking. So how to integrate about this? Negative 2 plus 1, negative 1 divided by negative 1, which is the negative 6 x to the power of negative 1. And what about this? This is the plus 2 x to the power of negative 2 from 1 to a. Okay? So substitute the values inside. What we get? I mean the limits. Oh, come on, come on. There we go. This is the negative 6 over a. This is plus 2 over a square. And this is negative 6 plus 2. Negative 6 plus 2 is negative 4, so plus 4. Okay, that is the first part. Guys, final touch. Second part, deduce the value of this integral when the a approaches infinity. So for the integral from 1 to infinity, dx is actually the limits of when a approaches infinity of this integral. Okay, so when it comes to this integral, we can't integrate it directly. Instead, we can use a variable to replace it. But for this case, we must use a and just obey it. Alright? Okay, I forgot the negative, my bad. Oh, maybe I just copied it. Will do. Okay, so here is the integral in terms of the limits that we have substituted over here. Now, what we can do is to substitute this that we have done from the first part inside the equation. Although this is the question number 17 that we have discussed over here, but instead I have to discuss with you one more questions, but it's still relating to the improper integrals. Okay? That means we are going to we have discussed 18 questions, but it's number 17 right now. So this is negative 6 over a plus 2 over a squared plus 4. So when you see, as a goes to infinity, what is the reciprocal of the 1 over a? What is the value of it? Where it approaches? What's the value it approaches? Approaches is 0, right? So if let's say a is 10, 0.1, 100, 0.01. If I keep adding the 0 behind of the 100, so what you can see over here, it is approaching 0, right? 0.00000 or something until 1. Where the 1, where you round off the 1, it is like negligible, it's approaching 0. So this is what I'm trying to explain with you by using the limits. Okay? So the answer for the B as it approaches infinity is 4. Okay? So 4 is our final answer. Okay. One more questions. Let me see. Okay, what about we can try to solve for the question 53. Okay? Improper. So, given there's an equation for the improper integrals, and now let's solve it. X equals to 3. How to integrate it? We can't integrate directly. We have to take out the limits, which is the limits. And we can't substitute a. If you substitute a, you will get the 0 already. We can't do that. So instead, I will put B for me, right? b approaches infinity from a to b of the integral 24x cubed x to the power of negative 3 is equal to 3. This we will get negative 12x minus x to the power of negative 2 from a to b. Like this. So what we get over here is negative 12b minus 2. Oh, sorry, this is infinity. Yeah, we must solve it in this way. Okay? Plus 12a negative 2. Okay. So, as b goes to infinity, the 1 over b, or even b squared, will approaching 0. That means this, you substitute the b is infinity inside, you will get 0. So now you have 12a to the power of negative 2 is equal to 3, and solve for a. So this cancel out. For the right hand side, you get 4. That means a squared is equal to 4. Okay? But what's the condition of the question? A must be positive constant. Okay? So, of course, each of you know that the a squared power 4, a squared is equal to 4. You solve it, you will get 2 or negative 2. But in this case, we take positive answer, which is a equals to 2. Okay. So, until here, if you understand, congratulations. You have mastered integration. Nice. So yeah, we have ended the discussion for the integration. So declaration still goes on. I declare that integration chapter 8 has officially done. Woohoo! Congratulations, guys. We have ended the pure mathematics syllabus in 9709 paper 1. Congratulations, you did it. But before we end this video, let's move on to the summary for chapter 8 integration. Guys, finally, this is the final touch before we end this video, as well as the chapter 8 integration. Okay, so this is the summary for the chapter 8 integration. First, integration is the reverse process of differentiation or antiderivative. Second, you have to know about the rules of the integration for indefinite integrals, no limits. Okay, so it's actually coming from the results of the differentiation. Okay, and you should realize why there is a plus C for the indefinite integrals. Refer to the reason over here. Hopefully you understand about it. Okay, third, about this, how to get the original equation, as I have taught you before. Okay, during our partial discussion just now. So first, integrate. Where is the gradient function? Yeah, dy dx, right? Or the f prime x. Second, after integrate, what you should do? Plus c. And how to get plus c? Boundaries. After the boundaries inside, the plus c is a real numbers. After we get plus c, what should you do? Equation over the curve. How to get equation over the curve? Rewrite again plus the value that you have found. That's all. Okay? So I'm not going to talk here too much. Talk about this too much. Let's move on to the definite integrals. Okay. So for the definite integrals, it has a limits for sure. Okay, just that the value must be in real numbers. And the definite integrals is actually the area under the curve. For the function is continuous. And of course, you still have you should know about the properties of the definite integrals that is derived from the rules on above over here. Okay? And area of the region can be proved by using Riemann sum, but you don't have to prove about it because it is out of syllabus. And what if you are dealing and solving for the negative areas, and how you how you make your corrections inside your workings. Okay? If there's a scenario over here. And the last thing last is the volume of the revolution. Either in the x-axis or in the y-axis. Okay? How much the degree it rotates. And why there's a pi? Because there's a circle or the disk. Alright? So I think you should remember this formula because these formulas do not exist in the MF19. And the last thing last is the improper integrals. Okay? We can't integrate this directly. How to do? The infinity must be substituted by a variable and take limits. This is the most important. And another one is the integral of the infinite discontinuity. How you should do? When the integral of fx, the bigger fx, is not defined when you substitute the b inside. Unless the series converges. Okay? So yeah, thank you guys for your support. Without your support, this couldn't be possible to be done. Okay? So here's my advice. Because now we have ended the syllabus for 8 chapters in Pure Mathematics 1. Alright? So thank you guys for your full support. Okay? I appreciate about it. And I can't stop expressing my heartfelt gratitude. Okay? So this is the end of the Pure Mathematics 1 9709 paper 1. Okay? So thank you for choosing my notes. If you feel like my notes are useful, do comment in the section below to express your appreciation. Okay? So here's my advice from Jonathan Goldfish. Please practice with the past questions for your upcoming exams on the February, March, May, June, and even the October, November series. Okay guys, best of luck in your external A-level examinations. Good luck, and I will see you in the next video. Because the next video, we are going to continue the further mathematics 9231 paper 1. Okay? So see you in the next video. Thank you guys for watching. If you find this video useful, please give a like with a subscribe and subscribe with the like button for the further updates. I will see you in the next video. Goodbye. Thank you for watching this video. Be sure to like and share this video and subscribe to this channel. I will see you in the next video. Goodbye.